Water is the foundation of civilization. Throughout history, societies have risen and fallen based on their ability to manage this essential resource. The story of how ancient civilizations engineered their water systems reveals not just technical ingenuity, but also the fragile balance between human ambition and environmental limits. In the river valleys of Mesopotamia, Egypt, the Indus, and China, early civilizations developed around predictable water sources. These societies built elaborate irrigation networks, canals, and reservoirs that transformed arid landscapes into productive farmland. The surplus food produced by these systems allowed populations to grow, cities to emerge, and complex social structures to develop. The Mesopotamians were among the first to face the long-term consequences of intensive irrigation. In the fertile plain between the Tigris and Euphrates rivers, farmers channeled water across vast fields of barley and wheat. But irrigation in this region carried a hidden cost. As water evaporated under the hot sun, it left behind dissolved salts in the soil. Year after year, these salts accumulated. Evidence from archaeological sites indicates that crop yields began declining in southern Mesopotamia around 4,000 years ago. Farmers responded by switching from salt-sensitive wheat to more tolerant barley. Eventually, even barley struggled to grow. Historians suggest that this gradual salinization weakened the agricultural foundation of several Mesopotamian city-states, reducing their economic power and making them vulnerable to external pressures. The Khmer Empire in Southeast Asia offers another perspective on water management and decline. Centered at Angkor, this civilization constructed one of the most sophisticated hydraulic systems of the medieval world. A vast network of reservoirs, canals, and dikes captured monsoon rains and distributed water throughout the year. This system supported a population that may have exceeded 1 million people. Research points to several interconnected stresses on this system. Tree ring data and sediment studies suggest that the region experienced severe droughts alternating with unusually heavy monsoons during the 14th and 15th centuries. These climate fluctuations strained the infrastructure. Canals silted up during floods and ran dry during droughts. The labor required to maintain the system increased while its reliability decreased. As the hydraulic network deteriorated, agricultural productivity declined. The economic surplus that had sustained Angkor's temples, roads, and administrative centers began to shrink. Population centers gradually shifted away from the capital. The decline was not sudden, but rather a slow unwinding, as the costs of maintaining the system exceeded its benefits. In the American Southwest, the ancestral Puebloan people built complex societies in one of North America's driest regions. At Chaco Canyon, they constructed great houses and established trade networks that stretched hundreds of miles. Their success depended on careful water collection through check dams, terraces, and channeled runoff from occasional rains. Evidence indicates that this region experienced a severe drought beginning in the late 11th century, followed by additional dry periods in subsequent decades. As rainfall became less reliable, the marginal agricultural lands that had supported outlying communities could no longer sustain crops. Communities began to consolidate or relocate. By the mid-12th century, the major centers at Chaco Canyon were largely abandoned. Historians note that the departure was orderly rather than catastrophic. People moved to areas with more reliable water sources, particularly near rivers and springs. The decline reflected an adaptation to changing environmental conditions rather than a sudden collapse. The Roman aqueduct system represents a different challenge in water management. Rome's 11 aqueducts brought millions of gallons of fresh water daily from distant springs and rivers. This infrastructure required constant maintenance. Channels needed cleaning, arches required repair, and the entire system demanded skilled engineers and substantial funding. As the Western Roman Empire faced economic difficulties in its later centuries, maintaining this infrastructure became increasingly difficult. The tax base shrank as trade networks contracted, and provinces were lost. Funds that once supported public works were diverted to military needs. When aqueducts fell into disrepair, cities could no longer support their previous populations. Urban centers contracted, and populations dispersed to areas where water was more directly accessible. The pattern across these civilizations reveals a common dynamic. Water systems that enabled growth also created dependencies. When environmental conditions changed, when maintenance costs rose, or when economic resources declined, these systems became liabilities rather than assets. The more complex the infrastructure, the more effort required to sustain it. Societies faced difficult choices. They could invest heavily in maintaining existing systems, redirect resources to build new infrastructure, or adapt by reducing population and complexity. Each option carried costs. The decisions made by administrators, limited by the knowledge and resources of their time, shaped the trajectory of decline. Modern archaeological and environmental research continues to refine our understanding of these processes. Ice cores, tree rings, soil samples, and ancient texts provide evidence of the pressures these civilizations faced. What emerges is a picture not of sudden catastrophe, but of gradual adjustment to changing circumstances. These ancient experiences with water management illustrate a fundamental principle. Civilizations depend on their ability to adapt to environmental and systemic pressures. When the costs of maintaining essential infrastructure exceed available resources, when climate patterns shift beyond the capacity of existing systems, or when complexity becomes unsustainable, decline follows as a slow accumulation of stresses rather than a single dramatic event. The archaeological record suggests that these transitions unfolded over generations, shaped by countless small decisions and incremental changes that, together, redirected the course of history. Understanding these patterns offers perspective on the relationship between societies and their environments. The evidence shows that civilizational decline rarely results from a single failure, but emerges from the interaction of environmental shifts, economic pressures, and the inherent limitations of complex systems. These lessons from antiquity remain relevant as modern societies navigate their own infrastructure challenges and environmental uncertainties.